I'm going to show you how to animate any view property in your NativeScript apps. Coming up now. All right, you've asked for more animation-related tutorials. Fox Pro says yes for animation with Angular, thanks. Fahmi says, thanks for all your videos. Please do NativeScript custom transition tutorial. Rahadur says, awesome tutorial. Yes, I want to watch more animation related from you. Sayanjin85 says, great tutorials. It opens up so many possibilities in order to make other kinds of animations. So that's what we're doing today. A little while ago, I posted a video here on this channel on how to create shapes in NativeScript. 2 different methods for doing that. Check that out. The link is here and in the description below. Now that we have the basics down with shapes, we're going to animate them. And we're going to use a technique that I'm going to show you in this video in upcoming videos. So make sure you subscribe and hit the little bell so you don't miss any of those videos. You've probably already seen a bunch of my animation tutorials on this channel, and I've used RxJS a lot in the past. Well, some people don't use RxJS. Maybe you're not using Angular, or maybe you don't want to import RxJS into your Core or Vue applications just so you can have animations. Well, this tutorial is for you because here we're using pure JavaScript. And of course, this technique will work with NativeScript with Angular, NativeScript Core, and NativeScript Vue. So what happened with CSS animations or NativeScript API animations? Well, you can still use those, but those have a limited number of properties that you can manipulate. With the technique I'm going to show you today, you can manipulate any property. All right, so we find ourselves here at the Hello World application. If I hit on the tab button, you can see that the counter decrements. What I want to happen is actually when I hit tap, I want this label to animate down and move down a little bit. So what I'm going to do is just go here into my XML. Here is the button that does the tapping, and here's the label that I want to move down. I need to grab a hold of this label in code behind. So in order to do that, I need to give it an ID. So I'm going to give it an ID LBL. And this tap right here, this tap event, right now is data bound to our view model right here. I actually want to handle that tap in the code behind right here. So in order to do that, I'm going to remove the binding syntax, and now it's just going to be handled in the code behind. So I'm going to copy this function here, and let's export a function called onTap. It's going to get args type event data. Now we got to get a hold of this label here, which is an ID of LBL. To get a hold of the label, we can just use the page. All right, so we already have the page right here. When we navigate to it, I can just bring that variable out here, set this to null, and then save off that page right there. So now I'll be able to access that page here. We're going to call getViewById, and for some reason it thinks it's any. So I'm going to type this to page, and now we can get IntelliSense on it. Okay, getViewById, and that ID is LBL. So I'm going to cast this as a label. All right, we need to import label. So if you haven't done that, there it is. Now, when I tap the button, I want to set the margin top of the label to, let's say, 200. Let's take a look at that. All right, the app restarts. I'm going to hit tap, and that label jumps right down. We don't want it to jump, of course. The idea here is that we're going to slowly increment it over time until it goes to 200. That's margin top is what I'm talking about. So we want it to go from 0 to 200 at about 60 frames per second. The way we do that is by using a setInterval. So setInterval is available in NativeScript as well as in the browser. This takes in a function that you want to execute, and then we want to provide how many milliseconds we want to execute this function. So we want to execute it every, let's say, 17 milliseconds. 17, where's that number coming from? Well, I actually rounded up. If we want to do 60 frames per second, that's 1000 milliseconds. So I do 1000 divided by 60. Each frame is going to be about 16.666. So that's rounded up to 17. Whatever is executed inside this function, this setInterval callback, that's going to be a frame of our animation. And setInterval is going to give us an ID that we can later cancel this interval, right? Let me call this timer ID, because we don't want this interval to keep repeating forever. We want it to stop after a certain condition is met. So what's our condition? Well, our condition is going to be time-based because we usually want our animations to happen over a certain amount of time. That's going to be the duration. So let's do this. I'm going to create constant start. This will keep track of when we started. So date.now, that's when the animation is going to start. And then we're going to figure out with every frame how much time has passed. So const time passed. Now we're going to get another time from that moment of that animation. And we're going to subtract the start time from it. Okay, so let's say we want the animation to take place over 2 seconds. That's 2000 milliseconds. So here I'm going to do a little check. If time passed is more than the time we want it to take place, so that's 2 seconds or 2000 milliseconds, then we want to stop this animation. So to do that, we use clear interval and we pass in that timer ID that we saved off. And then we can just return from this function. So that's going to clear the interval. It's going to stop the animation. But what happens every time the frame is not stopped if it's under 2 seconds? Well, here we're going to call another function to draw, and draw means whatever we want it to mean, right? So let's call draw. And we want to act on that label. So I'm going to pass in the label, but we also want to pass in the time that has passed so that the draw function knows which part to draw. All right, so I'm going to create a function called draw here. It's going to take in a label, which is of type label. And the second parameter is time passed, which is going to be a number. And this function is going to be responsible for setting our new margin. So up here is where I set the margin to 200. I don't want to do that anymore. So I'm going to delete that and I'm going to paste it down here instead. So instead of margin being 200 here right away, this draw function is going to be executed for one slice, one frame based on the time. So let's want this to travel 200 dips, 200 units over 2 seconds. Let's see, let's do the math here. It's going to be 2000 divided by 200. So the number is 10. So we need to do time passed divided by 10. So for each slice of time, which is 17 milliseconds in our case, we want to add 10 units. All right, so let's take a look at that. Now this is going to be animated, but it's not going to be as pretty as you want. Not yet. We'll get to that. So I'm going to hit tab here and you'll see that label move down. I'm going to hit tab here and that label move down. Now it looks a little bit smoother on iOS because of the simulator. My Android simulator is not that great here. So on a real device, this would look pretty smooth. And that's what's called the linear curve. We're going to get to curves in a bit. Now, how do we extract this to be more reusable? What if we wanted to do other cool animation things with this? Well, let's create a separate animation function that's going to handle this for us. A more generic function. I'm going to create a new file here called animation helper. Let's call it helpers because there's going to be a couple of functions in here. And that's going to be a TypeScript file. I want to export a function here called animate, not to be confused with the animate API that's available on Vues. This is our own animate function. You can call it JS animate if you want. So this function is going to take in some parameters. The first thing we want to tell this function is how long you want the animation to be. So that's going to be the duration. That's going to be a number. This is going to be milliseconds, of course. We're measuring everything in milliseconds. All right, that's it for the parameter for now. We're going to add more parameters here. But for now, that's enough. So there's the animate function. Let's go back here. Basically, we need this, right? This whole thing. So I'm going to cut this out of here and let's paste this in here. Okay, so that's going to be our start. You know what? We can use date now, or we can actually use new date as well here. All right, there's our set interval, which is going to be our main loop. We're going to calculate the time passed. Let me write this line over again, which is going to be new date. We can get the value of that, which is going to give us the milliseconds. And then start, we can get the value of this one. Okay, so that way time passed is going to be milliseconds. Now, because we already have the duration in this function, we can actually calculate the progress now. So I'm going to set let progress. This is the progress of the animation. You can actually use this to report progress back. We can do this in another video, but you can report the progress if it's necessary back to your caller. All right, so the progress is going to be the time passed divided by the duration. And sometimes this is not going to be a very clean number. So we want to do a quick check here. If progress, by the way, progress is always going to be between 0 and 1. We're basically normalizing this, right? So time passed is going to be a certain number of milliseconds here, and we're going to divide it by the total number of milliseconds, which is going to give us a fraction between 0 and 1. So progress must always be between 0 and 1. If it ever goes above 1, we're going to set progress to 1. And actually, we're going to use progress and not time passed to terminate our interval. So here, to terminate our interval, I'm going to say if progress equals 1, then we're going to clear the interval. And I'm going to put this at the end of this function so that we don't need to call the return statement here. There we go. Now here's the draw function. And this draw function is not going to be something that is going to be in our animation helpers. This draw function is going to be determined by whatever you're rendering. So it could always be different. That means we want that to be something that we pass in to our animate function. There's draw, and that's going to be a function. So we can even type it like this. Let's call that V for value. And here we're going to call that draw function for every frame, and let's pass in the progress. All right, so out here, when we tap that button, we want to call animate. Let's make sure we grab the right one. Yes, there it is. And we want to pass in first the duration, which is going to be 2000 milliseconds, and then a function. This function is going to take in that progress, which is the value, and it's going to do something with it. In our case, we want to set the label, margin top, and let's just, I don't know, do something here. I'm going to delete this draw function here, and I just want to test to make sure that this is working. So this is not going to be the final result of what we come up with here, but let's just make sure that we are getting some animation happening. And there we go. You can see that it's moving a little bit. So our animate function is working, and that's cool. Maybe I can even do times 100 here so that there's more movement to see. Let's take a look. Yep, there we go. So progress, remember, is from 0 to 1. If I multiply that by 100, so this is going to move from 0 to 100. Now, you can see that that curve is linear. The animation is not very smooth. It's just starts immediately going up with the same speed, and then it stops. We're going to add something called curves here. Now with CSS animation, you can use cubic Bezier curves, or if you're doing NativeScript API animations, you can pass in some of the enums that are available for the animation API. But we can actually design our own animation curve just using math. First of all, I'm going to show you a different way. If you don't like math, that's okay. Some of these functions are pretty out there. I'm going to show you a different way to get those animations easily. But first, let's talk about the basics. So here our animate function is being called first with the duration, then with that step function, and then we're also going to pass in one more function. In fact, I'm going to do that first after the duration. I'm going to pass in the curve. So the curve is going to be a function. Let's say it takes a time slice and it gives us back another time slice, like a mapping between two times. All right, so t to t, which means if it gets the time slice from 0 to 1, it's going to return us that same time slice from 0 to 1. So our second parameter here to the animate function is going to be that math function, that curve. Let's call it curve, and that's going to take in a number and return a number. Okay, so there we go. It takes in a number and returns a number. Now, how do we use that in here? Well, the number that we're going to pass and process through that function is this progress. So let's go ahead and create a constant here, and that's going to be the delta, which is going to basically skew our number from 0 to 1, and it's going to skew it based on the time. So we're going to call curve here and pass in our progress, and then we're going to get this delta. And instead of progress for the draw function, I'm going to pass in the delta. Let's quickly take a look at this. Now this should give us the same result, because here we're passing in t to t, which is just a mapping that returns the number itself. So if I click here, you can see that we're having the same exact animation. Okay, I'm going to increase this to 200 so that we can see more of a difference in the amount that label moves. Okay, good. It's still linear, but what can we do? Instead of passing in from t to t, we can pass in something else now. Let's say we wanted a more of a parabolic approach here, and we wanted to pass in another function. So we can create another curve function here. Let's call this function quad. This is going to take in t, and it's going to return math.power t, and then to the power of 2. So this is going to give us a nice parabola. All right. So all this does is just apply a math function to that time slice. So now instead of passing in this function t to t, we can pass in quad to process those numbers. Let's save that and let's check this out. So here it is on iOS, and you can see what happens here. It's slowly speeds up. So it starts out slowly, but then the label speeds up towards the end. Yeah, that's pretty neat. Okay, what else can we do with this? This is pretty cool. I'm going to paste in another function called circ. So this is going to do some more math on this. You know what? I got to be honest with you. At this point, I kind of lose this. And I don't know how to do these functions anymore because my math skills are a little bit rusty these days. But I know a workaround, and I'll show you that in a minute. So I'm going to pass in that circ in here instead. And that's going to give us an even different curve. So check it out. Look at that. It just snaps. It has a little snappy feel to it. Starts out slowly and accelerates. All right. So what about these functions? Where am I getting these from? You can always write them yourself if you know what you're doing, but you can always cheat too. And it's not really cheating, it's open source. I'm going to Google for D3 and these are easing functions. We can actually import these directly into our NativeScript project, or you can just go in here, take a look at the source code and look at all these functions. So for example, quad. If I take a look at quad, look at this. You can see the functions right there. So there's quad in, out. Let's take one that we haven't seen before, which is exp right here. Or you know what? Let's take a look at elastic. Those are always fun. So here's elastic in. All right, so I'm going to copy this. Let's go to our code. And I'm going to paste this in right here. Oh boy, tau. I don't know what tau is. Let me get these variables up here also, which apparently are needed. Okay, now it's happy. So now I'm just going to pass in elastic in to our animate function. Let's save this and let's check it out. Tap. Whoa, that is cool. All right, so that's elastic in. Now you can imagine that elastic out does the exact opposite and has a little rubber band effect. Let's see. I'm going to paste elastic out here and then send that into our animate function. Tap, boom. There is the cool effect that we all have been looking for, a little bounce effect. So how do we get this in here? Well, there is an easier way. Instead of copying and pasting these functions, we could just get the D3 library. So let's go to package.json. Actually, I'm just going to go ahead and open this up in my terminal by pressing Control backtick, and I can say npm install D3-ease -- save. So it's a runtime library, so we do need to -- save that into our dependencies, and there it is. Now this also has a nice convenient typings package in case you are using TypeScript, which we need to install also. npm install at types/d3ease, and this one's going to go to save dev as a dev dependency. Okay, and there it is. Now I'm also going to restart my simulators so that we get the new libraries in there. All right, while that's going on, let's go check this out in our code. So here's main page. I'm going to delete this elastic out and this tau business. Let's go back up here and I'm going to import star as D3 from D3ease. Okay, check it out. Now, instead of elastic out, I can just say D3 dot. Look at all these functions. All these are available to me to use. So I'm going to say ease. Oh, I don't know. What haven't we seen yet? Bounce in, out. Let's check that out. I'll save that. This is going to restart and let's tap the button. Bounce, bounce. How cool is that? So this animate function is pretty useful. Now, what if we didn't want to go from 0 to 200 like we are doing here? Right now, we only have the capability to go from 0 to something else, right? To some other number. All right. Well, what if we wanted to pass in the ability for us to go from a range of numbers, from one number to another, rather? Well, we can use another function for that. I'm going to paste this in and explain it to you. All right. So this function is amount from to. All right. We also need this animation range, which is just an interface. I'm going to paste that in. So the animation range has a from number and a to number. This way we can calculate based on the time, and time is from 0 to 1. We can calculate a ratio of where we're coming from and where we're going to, and based on that time where we need to be at that moment in time. So that's I hope that I explained that well, but amount from to lets us pass in, let's say if we don't want to go from 0 to 200, but we want to go from 100 to 500. Well, we can use this amount from to function to do that. So right over here, after delta, after we process it with our curve, we can get the location based on the amount from to function. Right, so this function takes in an animation range. So we need to get a range, and that range is something that the animate function doesn't decide. This is what the caller decides. All right, so let's pass in a range. Actually, we're going to pass in a function that gets a range. So it's going to be called a getRange function. And I'm just going to create a function here that's going to return an object, which is the range, the animation range. It has to be of this shape. It has to have a from property and a to property. So from is going to be, what did I say, 100? And to is going to be 500. And now our animate function has to take in another parameter, which is going to be the getRange function. And this is just a function that returns an animation range. There it is. Okay. So now amount from to needs to get an animation range, and we call getRange to get that. And then we can pass in that time slice, which is the delta, into the result of amount from 2. Once we get this value, that's the value that we're going to pass into our draw function, v. All right, let's check this out. I'm going to save all. I'm going to save all files, and let's go to our simulators. So when I tap this button, it should jump over to 100 and then slide to 500. Oops, and that didn't work, and our label just vanished off the screen. And that's because our range function is actually returning the real values of where our label should be. So our step function right here, our draw function, no longer needs to do this calculation. We can actually just remove that times 200, and this is no longer progress, it's going to be value. So the value itself of where we want that margin to be. All right, let's check this out. I'm going to hit tab here, and you can see that it jumped right to 100, and then from there it bounced out to 500, which is a little bit off the screen. Let's change this animation curve here. Let's do something a little bit easier to look at. Ease exponential out. Let's do that one, and we want to keep this on the screen. So I'm going to go from, let's say, 50 to 300. There we go. That's a little bit better. Okay. So why is this range useful? Well, let's say you have an object that's already a certain size that you want to resize. So let's do that next. Let's take care of this label. And instead of having text on the label, we're actually going to change this label a bit. I'm going to give it the class myLabel. It's no longer going to have text, but it's going to have a look. So let's go to app.css. I'm going to delete the comments here, and I'm going to add that myLabel class. We're going to give this a height of 100 and a width of 200 and a background color of red. So there's our label. Hit tab and it translates that rectangle. Cool. So one of the very elusive things in NativeScript for a long time has been animating widths and heights. Guess what? We can do that now using our animation function. What do we do for that? Well, look at this. Label margin top. Instead of margin top, all we need to do is just change this to height. Okay, so there's height. And it's going to go from 50 to 300. Well, our starting height is actually 100. So let's make it smooth. I'm going to set the starting height to 100. And let's check this out. So I'm going to hit tap, and there we go. Our label slowly and gently expands to a height of 100. How cool is that? Okay, well, let's take this a step further. What if we wanted to animate a couple of different properties of the label? We can do that here, right, in our draw function. I sometimes call it the draw function. Sometimes I call it the step function. Let's say we also wanted to animate the width. I'm going to make this a square to start with. So height 100 and width of 100. And let's go from 100 to 200. Let's save this. All right, so there's our square. I'm going to hit tap, and it expands in both directions. Very similar to the way scale works. Well, what if we didn't want to do that? What if we wanted to have the width go to different dimensions than the height? Well, now we're kind of stuck. I mean, there's ways around it. You can use this V to calculate the width based on the height, but they're always going to be tied to each other. What if we wanted to create two animations at the same time? Well, a naive solution would be to just say, I'm going to copy this animate function. I'm going to paste it here. And in this one, I'm going to animate the width. And the top one, I'm going to animate the height. This one's going to go the width from, let's say, 600 to 10, so it's going to get narrower, and this one's going to increase. All right, so let's check that out. Tap. Okay, so that works. But what if you had a bunch of animations to do? Well, every time you add an animation to that animate function, this is running on your one thread, on a single thread, because JavaScript here is a single threaded environment. So this animate function is creating two set intervals. For every time you call the animate function, it creates this set interval. So here we're calling this twice. That means we're creating two intervals. That's not very efficient. What if instead this animate function takes in a set of, let's say, animation definitions and executes them all using the same set interval? Well, that's a much better approach. Let's do that instead. So I'm going to paste in a new interface here, which is going to be a JS animation definition. It's going to have our getRange function. We've seen that one already. It's going to have our curve. It's going to have the step, which is like our draw function down here. And then it's going to have something called condition. We'll come back to that later. And this animate function, instead of taking in all these parameters, is going to take in a duration, and then it's going to take in a list of JS animation definitions, an array. So after we get our progress, what we can do is just loop through that array. So let's create a for loop here, which is going to be operating on all the definitions one at a time. Let's get one definition at first, which is going to be defs sub I. And we're going to make these 3 calls inside of that for loop. So here, the curve is actually going to be part of the definition. The getRange function is also going to be part of the definition because we're going to have different ranges for every definition. And the draw function is actually going to be called the step function. That's going to be def.step. I'm going to pass in the value there. Everything else remains the same. So here in our main page, before I call the animate function, I'm going to create some animation definitions. So my first definition, this is going to operate on the height of that label. So let's see, I'm going to press Control Space here. We're going to need to pass in getRange, which is a function, and that's this function right here. So I'm just going to copy and paste that. We need to pass in the curve function. That's going to be D3 ease exponent out, and we're going to need to pass in our step, which is this one right here. I can delete animate for now. And let's create a second definition. This is also going to have getRange. This range is going to be from 600 to 10. We're going to pass in D3 dot, oh, I need to specify that as a curve. D3 dot, you know what? We can even use a different curve here. So let's go with ease bounce out. And then we're going to pass in a step, which is this function right here. All right, so now we have our 2 animation definitions. You can have more now because we have a whole array that we can pass into the animate function. So I'm going to call animate here. We need to pass in the duration. I'll pass in 2000. And now we pass in an array of animation definitions, which is going to be def1 and def2. It's going to execute them at the same time, therefore saving our cycles, our CPU cycles, and running them all on the same interval, on the same loop. Cool. So let's do this. Tap, and there we go. So now both of those animations are running on the same loop, making this more performant and less CPU intensive. Now, how do we know that this animation function is done? Well, we can just use a promise-based approach here and return a promise. Let's go ahead and return a new promise here, which is going to resolve when the animation is complete. So there's our promise. I'm going to copy all this stuff out of here and drag it over inside the promise. All right, let's use some formatting here. Okay, so when our animation finishes, which is right here after the clear interval, I'm going to call resolve, and our promise is going to resolve. So now, after our animate function, we can call then or catch. I'm going to call then here and say console.log animation complete. Or you can even start a brand new animation there after the first one is done. Tap, there's our animation, and then we get a console log message that says animation complete. We're going to use this technique in upcoming tutorials. Like, I got a couple of really good ones coming up with a fab button that grows into a form and also a pager indicator that's animated. So we're going to be doing that in the next few weeks to come. In order to get those, make sure you subscribe to this channel and click the little bell so you don't miss any of those notifications. You can also follow me on Twitter. I'm at Digitalix over there, where I tweet about NativeScript and other related stuff like JavaScript and Angular sometimes. And I will see you in the next video. Thanks. Bye.